All right, bond association energy question continued. What I did, we're supposed to do the early or late transition state for the rate determining step. That's prop 2. We did that in parts D and C and D, I guess, or D. The transition state we determined because delta H equals plus 10 kilojoules per mole. Should have copied that too. Endothermic. Endothermic. Energy of the transition states up there, close to the products. What do we call that? Early or late? Yeah, products are at the end, right? I'm on the wrong document. Stop share. Find the right document. There we go. Oh, we got to do the explanation first. This is hard to get any shorter than what this is about as short as I can get it. In an endothermic reaction, you can use that short form without explaining that one. The TS energy, and on the previous document, I'm pretty sure I used TS, but I'm not 100%. No, that's okay. You just say TS. Okay, the TS energy is closer to the energy of the product. Here's where you have to make a thought leap, an elegant thought leap. Does it make sense if the energy is similar, then the actual appearance of the molecule should also be similar? Whereas if the energy is very different, they don't look the same. They have very different energies, they don't look the same, right? Like, young people all kind of look the same. They look young. They've got young appearances, right? Right? Old people look old, right? So, and you're basing it just on a number, age, right? Okay. Which is the definition of old. In an endothermic reaction, the TS energy is close to the energy of the products. So it should make sense. So the TS should resemble. You're using energy to estimate appearance. You got to acknowledge you're doing that. The products more than the reactant. And what's the only logical word, late or early, for that black sentence? More than reactant. It resembles products more than reactant. Products. Products happen at the end. Yeah, so late. Late TS. Endo is always late. That's, the diagram says it. And now you're going to diagram the TS. Before you do that, you have to use that short form. Square box, and a telephone pole on the top right means transition state. Got to have the box. Got to have the telephone pole. Now I'm going to ask you a question. Look at the mechanism. What is the only atom that is transitioning from one place to another? I need the name of an atom. Just look at the mechanism. Which atom is moving? The I used to be bonded to Br, and now it's bonded to carbon. It's the only one that moved. The I is transitioning. And if you're late, that means the I should be very close to carbon when you're in the transition state, not close to bromine. Okay? Where's the I at the end? Is it with carbon or bromine? Carbon. So in the transition state, it's closer to carbon. And it's making this bond to this carbon, is that the molecule? It is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And it is almost entirely gone from bromine. See, if it was early, the I would be way over here. That's how you do, that's the only two diagrams, people. If it's late, it's closer to where it is in the product, right there. If it's early, it isn't early here, but if it was, you'd put it over here, close to bromine. Keep the dot, dot, dot. What kind of bonds are these? Partial bonds. It's the same as our partial triangle from mercury, remember? And there you have your late transition state. So there's 7 points right here.
You don't do the graph. You do like
No, the graph was just for me to figure out if it was late or early. And you'll probably have that memorized by exam day, right? So yeah, I put the graph on answer keys before, and students think that's the answer. Like the endothermic graph gets you 0 points. We're saying, do you know what endothermic means in terms of late versus early? And then we're going to finish up with a couple new things that are, they're the simplest thing in the whole thing. There's something we haven't talked about yet, and it's a bad thing. And if you look at the question, there's a word that looks like it's a bad thing here in the question. Oh, we don't have the question on this year's exam. We can stop. But we're not going to. Because on yours, questions H and I will be there, and I don't want you saying, but we didn't do H and I here. Anyway, you're not going to say it. Nobody talks like I pretend you talk. I know that. You never take it personally, right? What's he trying to do? I just try to be a goofy student. That's all I'm trying to do. And don't say, wait, he sounds kind of like me. Is he saying I'm a goofy student? I'm not doing that. Okay. All right. What am I doing? I'm a goofy student now. Sorry? Oh, question H and I. We got to put the question on the page, right? I'll put on the next one. These two questions will be on your test as well. H, give a mechanism for 2 termination steps. That doesn't sound good, right? Sorry? We have G and H? Oh, we call it G. And I never did a G? Oh, it's not as bad as I thought. Well, I had the H, though. Was that the exact wording? Pretty close? H and I. Okay, here's the H now. So we haven't done G yet. It's good I copied it, right?
So I think you have to do just H. No, G's already in the question.
Yeah, but we haven't done it yet, so it's good that I typed it here. That's all I'm saying.
Yeah.
And then H and I are new. We haven't seen either one of these. No. Explain why termination steps are undesirable. Wow. That sounds personal. And I, explain how termination steps can be avoided. You want point counts, right? 2 points, 2 points, 2 points, 2 points. I know, it's rocking, isn't it? Yeah. We should just skip it, right? No. Okay. I'm a little bigger. Wow, it thinks there's a lot in that box. Oh, I did all for the page. I don't know, maybe get that up to 22. Okay. Termination happens when radicals meet radicals. It's very bad. So we could have Br radical meet a, this is G. I'll call it T1. How's that? If a Br meets up with a Br radical, they just meet up and make Br2. And my explanation for H, I love doing beside it, because if you're using Br this way, then you're not using Br this way, which is what you desire. Right? If you don't have Br dot, can you do prop 1? You can't. There's no Br dot. How did you get rid of Br dot? Well, a termination step happened because you weren't careful. So this killed prop 1, and that's a perfectly fine answer for H. It killed the reaction that required Br dot. And the worst T2 is if Br dot hooks up with the carbon radical. This is a double killer, because it's going to kill prop 1. It's using Br dot in an undesirable way, but it also kills prop 2 that requires carbon radical. And it gives us this undesired product. Not H. This was G part T2 again. Kills prop 1 and prop 2. And I always get asked, how do you know it kills prop 1 and 2? Well, prop 2 is right here, and it needs a carbon radical, and you're telling me your carbon radical did this instead. That means it's not doing prop 2. And earlier on, we saw prop 1 use the Br radical right here. If Br radical's used up by another termination step, you can't do prop 1 either. So both are very bad. How do you make them not happen? The only question where you can literally copy this answer and guarantee 2 points. Yay. We had a student come up with a shorter version. I can't remember her version. I'm going to give mine. Keep radical concentrations low. Now, I'm just going to write that sentence, but I'm going to verbally explain why that's a good idea. I want radicals to react with non-radicals, because that's what happens in the 2 propagation steps. Radical, non-radical, radical, non-radical. I don't want them meeting radicals. So if radical concentration is high, radicals will meet radicals, right? If it's low, then you have all this unreacted stuff surrounding it and all this stuff surrounding it, not radicals, and then you're going to get your prop steps. And how do you do that? Simple. Turn on, in this question, we use what, H nu or delta or what? We use the delta. Delta, which is heat, right? For only a short amount of time. And I hope that makes sense. If it's on for a long time where you're popping a covalent bond in half to make 2 radicals, if that keeps going on for a long time, you're getting a high concentration of radicals. If you only happen for like 2-3 seconds, then that radical will not find another radical. There's not hardly any radicals, right? It's going to meet up with a carbon that has hydrogen, and that's prop 1. And then you make a radical during that. It meets up with a halogen, BRI in this case. And that's the way you want it to go. There's your 2 points for the black. And you just copy it. If you want to use the BB modification, hers was a little shorter than mine. It's in the morning section. I think she cut out about 5 words there. And that's at 10 drop. That means time to quit the video. Got a free dot there.